Welcome. In this video, we are going to build a complete machine learning pipeline in Python using a real-world dataset, Airline Passenger Satisfaction from Kaggle. I will add a link of this dataset in the video description. You will learn each step of the machine learning pipeline from data wrangling and feature engineering to the model training and evaluation, and even model stacking. We will cover the most common models and use and apply use cases along the way. And by the end, you will have a clear, practical understanding of how to structure machine projects from scratch. Let's get started. A machine learning pipeline is a structured sequence of steps that takes raw data through a process of ingestion, pre-processing, modeling, evaluation, and deployment. Machine learning pipeline, it ensures reproducibility, minimizes data leakage, and helps optimize performance at each stage, from data cleaning to final model predictions, make the entire workflow more efficient and scalable. As you can see here, the first stage highlights the data processing, starts with importing libraries, pandas, NumPy, sklearn, matplotlib, C, seaborn, etc. Then we have the dataset importing, whether it's a CSV files or Excel files. Number 3 highlights data understanding, and in this stage, we focus on data dictionary, reading the data and definitions on Kaggle or in the data source itself to understand the data and variables. We also use functions such as describe, info, and histogram to get more into the data. Then we have the data wrangling or data cleaning, where we focus on detecting missing values, outliers, changing the types, try to fix the data and make it complete in order to help us to train the machine learning model later on. Then we have the feature engineering. Feature engineering focus on the transforming the current variables into more valuable features that our machine learning model can understand. And I have another video where I highlight the details of and the most common techniques used in feature engineering, such as label encoding and ordinal encoding and embedding as well. So feel free to check my other video as well. Back to feature engineering, we have most common techniques such as feature scaling, standardization, and normalization. Then we have dimensionality reduction. We don't usually use BCA or dimensionality reduction in each and every machine learning model, but it also wants to highlight it because sometimes our dataset is pretty dense and need some techniques of or dimensionality reduction. We have the true and core nature of machine learning, where we split the data into training, validation, and testing. Then we have the model training, which we choose the few models. Usually we start with a random forest because it's pretty neutral, and it also can highlight or define the parameters we will use, doesn't fully get impacted by the order of the features or the transformation variables, and that's why we start by random forest as a baseline. Sometimes we use PyCart library because it highlights different multiple models and techniques we can choose from as a baseline. Then we have the cross-validation while training and tuning the data. Then we have cross-validation in hyperparameter tuning. Then we have models evaluation and feature importance. And finally, model stacking after having a good individual models. So basically we start by training, train test split, and then the model, and then cross-validation, hyperparameter tuning, and then we see the best model, then we arrange or apply feature importance, so we can choose the most important features of the dataset and use it to train and predict the target response and eliminate the other unimportant features. Then by applying the model stacking, we have good prediction model with the highest accuracy or highest precision score. We will use it to train the testing subset. And that moves us to the final part, training the best model, then the final model evaluation based on AUC and ROC score, accuracy or F1 score, etc. Then applying the best model on the test data. So this is the 16 steps of traditional machine learning pipeline. Feel free to pause the video and read each one again. Then we have machine learning pipeline. These are most common use cases that can be tackled with the traditional and modern techniques. So as you can see, the first part here on the left, we have the use cases, build a risk analysis model, We can use also ML pipeline or machine learning pipeline to segment users' preferences or using clustering analysis. The third use case is forecasting cancer patient survival. The fourth use case is classify fraudulent transactions using random forest. Okay, using random forest is not the only applicable one. You feel free to use XGBoost, CatPost, LightGBM, decision tree, or even like big a regression. Like if we are classifying, then we will use a logistic regression technique, or naive Bayes, or support vector machines, etc. And finally, movie or Spotify recommendation app using content-based filtering and use user-user collaborative filtering. It's also a quite advanced technique or use case we can apply machine learning pipeline to. And on the other side, on the right side, we have the models and deployment. So we have machine learning, supervised learning, and clustering. We have also association rules mining. We can be integrated into ML ops pipeline for automation, monitoring, and deployment. We can also, instead of using machine learning pipeline, we can create deep learning pipeline. And finally, the most use case is in simple models, stacking, blending, XGBoost, CatPost, etc. And down below, you can see here that machine learning pipeline stages started by the data ingestion, then pre-processing, and then modeling, and then evaluation, and finally deployment. And here in this slide, we're starting by defining the stages of machine learning pipeline. So first, we have the data wrangling, aka data processing, that includes detecting missing values by handling properly and by applying imputing methods to the missing values, meaning that we have the NaN or the Na values. We replace these Na values with median or mean or mode, okay? But in the pipeline, we usually focus on mean or median, and these are the imputing methods. Then another technique is detecting outliers. But first, you need to understand the outliers and their impact before decide what you are gonna do. Are you gonna delete them or replace them with the most frequent feature of the column? Then we have detecting duplicates. Filter the data frame to check if there are duplicates across other variables on a row level before deleting them. Okay, and we have also data visualization. I like this part because data visualization not only helps with the data cleaning, but also give you more understanding about the data itself. So we have histogram that check data skewness, if it's a right skewed or it's a left skewed. And then we have heat map. We use heat map to check features correlation. Additionally, visuals helps to identify if one of the variables is capped or skewed, and that help us to understand the data better than build solid assumptions and choose the right machine learning method. Then we have a check correlation and identify multi-collinearity. Okay, so if the variables are correlated between each other, that can trigger multi-collinearity, which can affect model generalization later. Okay, and multi-collinearity can make machine learning models unstable, especially with linear models. Detecting them early is beneficial, and we can use Pearson correlation matrix for this purpose. Another component in machine learning pipeline defined by feature engineering. Most common methods that can transform and maybe create new features for solid ML performance or machine learning performance. For imputation, we use simple imputer. All these functions, by the way, are under sklearn library. Okay, and remember, always impute before scaling or encoding. All right, for feature engineering, we use, if the variables are numeric, then we can apply minimax scalar or standard scalar. If the variable is categorical, then we use one hot encoder or ordinal encoder. Okay, and then we have feature transformation. We use column transformer. And then finally, for dimensionality reduction, we use BCA, the most common technique in dimensionality reduction. One important point to highlight that machine learning might require applying dimensionality reduction, but not in every case. You basically intertwine BCA and column transformer inside the feature engineering pipeline. And we have also model training pipeline. Starting with a train test split, define the parameters, such as learning rate, max depth, etc. We use while training the model. Then we create for loop that contains the machine learning technique we will use, then tuning and the k-fold and evaluation metrics such as accuracy score. Then we define the machine learning technique. Usually as a data scientist, we start with a random forest as a baseline model, but feel free to use another machine learning techniques such as support vector machines, XGBoost, etc., even naive Bayes. It's really applicable about every case, or it's related to the task at hand. And I want to emphasize that model training pipeline specific technique, it can be any of those. Feel free to use naive Bayes or neural networks. The main focus of this video is to sort the steps used to build machine learning pipeline. That's all. Okay. And then we have defined the hyperparameter tuning and cross-validation techniques, such as grid search, CV, or random search CV and k-fold. Then we train the model number of times, let's say 10 times, pick the best model with the average accuracy rate, and then we stack the models using Optana method. And then we stack the models using Optana method and choose the best model with the best accuracy or AUC ROC score to use it on the test subset and predict the classes, aka target response. And finally, save the new prediction in a new CSV file. And another final component in machine learning pipeline is the model evaluation matrix. For classification tasks, the evaluation can be accuracy, F1 score, AUC ROC score, precision, recall, confusion matrix. But remember that accuracy can be misleading if the data set is imbalanced, so we can't rely on accuracy alone. Then for regression models, we have RMC or MAE. We have also R2 score or MAB, mean absolute percentage error, useful in business contexts. Aside from model evaluation, explain model logic and interpretation is crucial. We have overfitting, underfitting, model generalization, variance, bias fluctuation, or variance and bias trade-off. We have also explainability and feature importance, and visuality using bar H or bar horizontal plot. Okay, so aside from the evaluation matrix, you need to consider these components as well. And now let's practice. So basically we have airline passenger satisfaction. I will add the link of this dataset in the video down below. And the techniques I will use are catpost, XGBoost, LightGBM, and random forest. And these are the evaluation metrics. And that's it for today. Thanks so much for watching. You have now seen how to build a full machine learning pipeline from start to finish using real data, real models, and practical techniques. If you find this helpful, give it a like and subscribe for more hands-on machine learning and data science content. And the dataset and code are linked in the description, so feel free to try it out yourself. Got questions or want to see another dataset in action? Drop a comment below. I respond to all of them. See you in the next video. Bye.